Join me as I dive into the mind-bending world of quantum tunneling and try to figure out just what makes this mysterious power tick. Quantum tunneling is a phenomenon that has left scientists and theorists scratching their heads for decades. It's a fundamental aspect of quantum mechanics that has far-reaching implications for our understanding of the universe. You see, classical physics tells us that a particle can't just jump from one side of a barrier to the other without somehow crossing the space in between. But quantum tunneling says otherwise. It suggests that particles can exist in two places at once, defying the laws of classical physics as we know them. This raises some serious questions. If particles can tunnel through barriers, what does this mean for our understanding of space and time? Does it mean that the fundamental laws of physics are broken, or are we just looking at the world in the wrong way? This paradox is even more mind-boggling when you consider the concept of wave-particle duality. You see, on the quantum level, particles can exhibit both wave-like and particle-like behavior, depending on how we observe them. This blurs the line between the macro and micro worlds, making it difficult to understand what's really going on. But that's exactly what makes quantum tunneling so fascinating. The implications of quantum tunneling are huge, and they have the potential to revolutionize the way we approach technology. Imagine being able to create ultra-secure encryption methods that use quantum tunneling to transmit data. It's like having a secret code that's virtually unbreakable. And that's not all. Quantum tunneling could also be the key to unlocking new sources of clean energy. So, how does quantum tunneling actually work? Well, it all comes down to probability. You see, on the quantum level, particles don't have definite positions or trajectories. Instead, they exist in a state of superposition, where all possible outcomes exist simultaneously. When a particle encounters a barrier, it can tunnel through it by exploiting this probability. It's like finding a hidden door in a maze. The particle doesn't need to follow the traditional path, it can just tunnel through the wall. This concept can be difficult to visualize, but imagine a wave function that describes the probability of finding a particle at a given location. When a particle encounters a barrier, its wave function essentially tunnels through the barrier, allowing it to appear on the other side. It's a mind-bending concept that challenges our classical understanding of reality. The applications of quantum tunneling are virtually limitless. In the field of quantum computing, quantum tunneling is used to create quantum bits, or qubits, that can process vast amounts of information simultaneously. And in the field of nuclear fusion, quantum tunneling could be the key to unlocking new sources of clean energy. But what does this mean for our understanding of the universe? Does it suggest that the fundamental laws of physics are broken, or are we just looking at the world in a new way? The truth is, we still don't fully understand the implications of quantum tunneling. It's a mysterious power that continues to defy explanation. In conclusion, quantum tunneling is a mind-bending phenomenon that has the potential to revolutionize the way we approach technology. It's a mysterious power that continues to defy explanation, and it's an area of research that's still very much in its infancy. So, what do you think about quantum tunneling? Do you think it's the key to unlocking new sources of clean energy? Or do you think it's just a weird side effect of quantum mechanics? Let me know in the comments below, and if you're interested in learning more about quantum mechanics, be sure to check out our video on the double-slit experiment.